let us start a new chapter, that is chapter number 4, structure of the atom. This is about the structure of the atom. You can see centralized location of nucleus and electrons are revolving in a circular orbit. In the nucleus, there are two particles, that is neutron and proton, and electrons are revolving around in a circular orbit or energy shells. Now, atom, as we already have studied in atom and molecules chapter, actually atom has charged particles. Atom have three subatomic particles. They are electrons, protons and neutrons. Electrons are negatively charged particle. It is denoted by a small e with negative sign. Protons are positively charged particle represented as small p with positive sign, and neutrons have no charge denoted by small n. Electron has the mass of 1 by 2000 the mass of hydrogen atom. It is having very small mass or negligible mass. So mass of proton is equal to mass of hydrogen atom and it is taken as 1 unit. And mass of neutron is also equal to mass of hydrogen atom and taken as 1 unit. So electron mass is negligible, that is 1 by 20 or 1 by 2000 mass of the hydrogen atom, and proton and neutron has equal mass as of hydrogen atom. Now coming to the discovery of these subatomic particles, electron, proton and neutron. Now first of all, in 1900, J.J. Thomson discovered the presence of negatively charged particles called electron in an atom. And in 1886, E. Goldstein discovered the protons. He discovered a radiation in the gas discharge tube known as canal rays, and they were later on considered as positively charged and given the name proton. And in 1932, Chadwick discovered the particles having no charge in the atom and he named it as neutron. So electron by J.J. Thomson, proton by E. Goldstein and neutron by Chadwick. Different scientists have proposed the different models of an atom after discovery of three fundamental particles, that is electron, proton and neutron. So first of all, structure or model proposed by Thomson. According to Thomson, an atom is similar to Christmas pudding. The pudding had positive charge and electron having negative charge were like plums on the pudding, or you can say the watermelon, isn't it, like pudding, and the seeds of watermelon are like electrons. They are scattered in between the atom. He proposed an atom consists of positively charged sphere and the electrons are embedded in it. Means whole atom is positive and electrons are embedded in between them. The negative and positive charge are equal in magnitude. Number of negatives are equal to number of positives. So electron or atom is electrically neutral. The next model proposed was the Rutherford's model of an atom. Now Rutherford allowed a beam of fast moving alpha particle. Alpha particles are the helium nucleus having 2 unit positive charge and 4 unit mass. So he allowed a beam of fast moving alpha particles having positive charge to fall on a thin gold foil. He observed that first, most of the alpha particles pass straight through the gold foil. No obstruction, they pass straight away. Second observation was some alpha particles were slightly deflected by small angle. They deflected by a small angle. And third observation, few alpha particles, very few, they appear to rebound or they revert back. Now, by three observation, three conclusion has been derived from Rutherford alpha scattering experiment. First observation, most of the space inside an atom is empty because it is seen that alpha particles pass straight through the gold foil. So it is interpreted that space inside the atom is empty. Second observation was some of the alpha particles deflected back with small angle. So it has been interfered that atoms had a small nucleus having positive charge. So same charge repel each other. That's why small deflection angle has been made. And the third observation was only a few particle of alpha rebounded. So it was considered that the size of nucleus is very small as compared to the size of empty. That is, atom is big in size, but most of the atom part is empty. Only a few small portion is occupied by the tough. So Rutherford model of an atom is: an atom has positively charged nucleus at its center, and most of the mass of the atom is in the nucleus. Second is the electron revolve around the nucleus in different orbits. And third is size of nucleus is very small as compared to size of the atom. Now, defects of Rutherford model of an atom. According to the theory, any particle in the circular orbit would undergo acceleration, and during acceleration the charged particle would radiate the energy. So the revolving electrons would lose energy while it will radiate the energy, and it falls into the nucleus. An atom will become unstable. We know that atoms are stable, so energetically Rutherford atom could not explain the stability of the atom, so it was discarded. Now, Niels Bohr has proposed another model of an atom which was energetically stable, and it was well explained. He explained an atom has positively charged nucleus at its center, and most of the atom mass is concentrated in the nucleus. Secondly, the electrons revolve around the nucleus in spherical orbits is called discrete orbits. They have particular energy levels, or discrete orbits they are. These orbits are called shells or energy levels, and are represented by letters like K, L, M, N, O, etc., or numbered as 1, 2, 3, 4, etc. Now, while revolving in the discrete orbit, the electron do not radiate energy. According to previous theory, the electron will radiate the energy, but when they are in the discrete orbit or energetically stable energy shell, they will not discrete, or they will not radiate energy. Now, talking about distribution of electrons in different shells, the distribution of electrons in the different shell was suggested by Bohr and Bury. The following are the rules of filling the electron in different energy shells. First is maximum number of electron in a shell is given by formula 2n square, where n is the number of shell, that is K is having 1, L is having 2, M is having 3, etc. So for the first shell K, let us calculate number of electrons. Formula is 2n square. 2 into value of n for K shell is 1. So 2 into 1 is square. So 2 into 1 means 2 electrons. So K shell will have only 2 electrons. Likewise, we can calculate for L. The value of n for L is the 2. So 2n is square. So 2 into 2 is square. So that is 8 electron. For M, value of n is 3. So 18 electrons. For N, value will be 4. It is 32 electrons. So 2, 8, 18, 32, and so on. The maximum number of electron that can be filled in outermost shell is 8. It is also octet rule, and electrons cannot be filled in shell unless the inner shells are filled. So for first K will be filled, then L, then M, likewise. So these are the composition of atom of first 18 elements. Better you will write in the notebook, then it will be clear to you. You can see the distribution of electron in its particular energy shells, KLMN, in the systematic form up to 1 to 18 elements. Now, the next terminology is valency or valence electron. Let us understand. The electron present in the outermost shell of an atom is called valence electron. As we have seen, K, L, M, N shells are there. The electron lying in outermost shell is known as valence electron. And valency is the combining capacity of an atom. That means a number of atom to make the octet configuration, number of atom electron accepted or donated by the particular atom is known as its valency. For example, if an atom outermost shell is completely filled, they are inert or they are less reactive. Their combining capacity or valency will be 0. Inert gases are like all 18 group elements: helium, neon, krypton, argon, xenon. They have the outermost 8 electron and they are considered as octet configuration and they are stable. If any atom's outermost shell is not completely filled or octet is not there, it is not stable, and they will try to attain the stability by losing or gaining or sharing the electron to obtain the octet configuration. So number of electron lost, gained or shared by atom to attain the octet configuration is known as combining capacity or valency of the element. Example, hydrogen, lithium, sodium atom can lose one electron and they can become stable. Their valency is 1. Magnesium 12 is there, 282, so it will lose the 2 electron, its valency is 2. Aluminium having 13 atomic number, 283 configuration, so this will lose 3 electrons, so the valency is 3. And carbon can share 4 electrons, so its valency is 4. Again, fluorine can gain 1 electron, so it will become stable, so its valency is 1. Oxygen gain 2 electrons, so valency is 2, and nitrogen gain 3, so valency is 3. Now, atomic number and mass number of the atom. What is atomic number? It is represented by capital Z. It is the number of proton present in the nucleus of the atom. So, number of proton present in an atom is known as its atomic number. Atom is electrically neutral, so number of electron is equal to number of proton. So all atoms of element having same atomic number, like hydrogen atomic number 1, helium atomic number 2, lithium atomic number 3. That means they are having the proton 1, 2, 3 in it. Mass number is the sum of number of protons plus neutron, n plus p, in the nucleus of atom is known as mass number. So carbon has mass number 12, 6 proton plus 6 neutron. Aluminium has 13 proton, 14 neutron, that is atomic mass will be 27. Sulfur has 16 proton and 16 neutron, atomic number will be 32. So how we can represent an atom? By symbol, nitrogen is represented, atomic number is written as 7 left hand side, and 14 is the atomic mass or mass number. Isotopes. Isotopes are atoms of same element having same atomic number but different mass number. Atoms having same atomic number and different mass number are known as isotopes. Example, we can see hydrogen has 3 isotopes: protium, deuterium and tritium. Hydrogen 1, hydrogen 2 and hydrogen 3. Having same atomic number, that is 1, and having the different mass number 1, 2, 3 in case of protium, deuterium and tritium. Likewise, carbon has 2 isotopes, carbon 12 and carbon 14, having the atomic number 6 and having different mass number 12 and 14. Chlorine has 2 isotopes, chlorine 35, chlorine 37, having same atomic number, that is 17, and different mass number, that is 35 and 37. Other atoms are isobars. Isobars are atoms of having different element having same atomic number but different mass number. Same mass number but different atomic number. For example, calcium and argon. You can see calcium is also having the atomic mass 40, argon is having same atomic mass 40, but their atomic number is different. Calcium is having atomic number 20 and argon is having atomic number 18. Likewise, the combination of iron and nickel, you can see both iron and nickel has the atomic mass 58, but atomic number of iron is 26 and of nickel is 27. So they are isobars.